The objectives for this video are to learn how to calculate the minimum sample size needed for an interval estimate of a population proportion. A polling company would like to estimate to within 2 percentage points the approval rating of a candidate for an upcoming election. They would like to be 95% confident about their estimate. The formula for calculating the sample size necessary for estimating a population proportion with specific precision and confidence includes the z-score associated with the given confidence level and the specified precision. Note that the formula also includes the sample proportion estimate of the population proportion. This would not yet be known. This calculation gives us the required sample size. Once that is determined, the sample would be drawn and the sample proportion could be determined. So what do we do for the p-hat and q-hat parts of this formula? If we have the sample proportion for a previous study of the same population, then that can be used. But if there is no previous estimate, then we must do something else. Let's look at the table that shows the values of p-hat, q-hat, and the product of p-hat and q-hat. Recall that q-hat is the complement of p-hat. In other words, we can find q-hat by subtracting p-hat from 1. So when p-hat is 0.1, q-hat is 0.9, and their product is 0.09. When p-hat is 0.2, q-hat is 0.8, and their product is 0.16. As we continue through this table, let's note that the maximum value for the product p-hat q-hat is 0.25. So in the absence of a reliable estimate for p-hat, the value p-hat times q-hat equal to 0.25 should be used to give us a sample size that is sufficiently large to guarantee an accurate prediction. The z-score that allows for 95% confidence can be found in a table or found using the TI graphing calculator or any one of many statistical software packages. The t-table shows us, on the bottom row, that when we desire 95% confidence, the associated z-score should be 1.96. So, filling in the formula with 0.25 for p-hat times q-hat, 1.96 for z, and 0.02 for our margin of error, we find that a sample size of 2,401 would allow us to estimate the approval rating for the population with 95% confidence to within 2 percentage points. In this video, we learned how to calculate the minimum sample size needed for an interval estimate of a proportion.